In the last video, we introduced normal distribution and standard normal distribution. In this video, we will study the relationship between normal distribution and standard normal distribution, and we will show some applications. First, let's recall the normal distribution. If x follows a normal distribution with the parameter mu and sigma, the density function is given here. For standard normal distribution, the density function is given here. Let's first prove a very useful fact. If x follows a normal distribution with the parameter mu and sigma, then x minus mu divided by sigma follows a standard normal distribution. In other words, we can convert a normal random variable x to a standard normal random variable by subtracting the mean and divided by the standard deviation. Now let's prove this. So we want to prove that the distribution function for x minus mu divided by sigma is the same as the distribution function of standard normal. So this is equal to probability x is less than or equal to mu plus a sigma. And this is equal to the integral negative infinity to mu plus a sigma. And the integrand would be the density function of the normal distribution, or the density function of x, which is given by 1 over square root of 2 pi sigma e to the negative 1/2 x minus mu divided by sigma squared d of x. Note that we write slightly different here compared with here, but it's the same thing. Now, let's do a u substitution. We're gonna let this piece equal to u. So we're gonna do a u substitution. U is equal to x minus mu divided by sigma. So d of u is gonna be equal to 1 over sigma d of x. So this piece is gonna be equal to 1 over square root of 2 pi sigma e to the negative 1/2 u squared, and d of x, based on this equation, d of x is equal to sigma times d of u. So this is equal to sigma d of u. We can cancel this to sigma. And we also need to figure out the range of u. Now, first, x is ranging from negative infinity to mu plus a sigma. And u is equal to x minus mu divided by sigma. So it's easy to see that the range of u would be from negative infinity to a. Now we can just write this down clearly, right? So this is equal to negative infinity to a 1 over square root of pi 2 pi e to the negative 1/2 u squared d of u. And this integrand is just the density function of a standard normal. And this whole thing is the distribution function of standard normal. So we just proved that the distribution function of x minus mu divided by sigma is the same as the distribution function of a standard normal. So we thus proved that x minus mu divided by sigma follows a standard normal distribution. Now next, let's look at some applications. The first, if x follows a normal distribution with mean equals to 1, variance equal to 9, we want to calculate the probability x is between negative 2 and 5. The second question, we want to find a such that the probability x is less than or equal to a is equal to 0.8. The first one, probability x is between negative 2 and 5. And this is equal to, recall that we can convert x to a standard normal by subtract the mean and divide by standard deviation. Now, based on the assumption we have mu is equal to 1, sigma is equal to 3. because the sigma square is 9. So we subtract mean divided by standard deviation on all sides of this equation. So 5 minus 1 divided by 3, negative 2 minus 1 divided by 3. Now this is equal to probability. Now we can write this entire thing as z because this is standard normal. So this is going to be the same as z is less than or equal to 4 over 3 greater than or equal to negative 1. And this is equal to probability z is less than or equal to 4 over 3 subtract probability z is less than negative 1. And this is equal to phi of 4 over 3 subtract phi of negative 1. And this is equal to, we can use R to do the calculation. So this is equal to P norm 4 over 3 subtract P norm negative 1. So this is equal to 0.775. Okay, let's look at the second question. Find A such that the probability x is less than or equal to A is equal to 0.8. Probability x is less than or equal to A is equal to 0.8. Now, the left-hand side, we can write as follows. So probability x minus 1 divided by 3 is less than or equal to A minus 1 divided by 3 is equal to 0.8. So again, we can write this piece as z, which is standard normal. So this is equal to probability z is less than or equal to A minus 1 divided by 3, and this is equal to phi of A minus 1 divided by 3. So this must be equal to 0.8. Now, this implies that the A minus 1 divided by 3 is equal to phi inverse 0.8. Now we can solve for A. A is equal to 3 times phi inverse 0.8 plus 1. Now all we need to calculate is this formula. Again, we can use the R. This is equal to 3 times Q norm. Remember that the inverse function can be calculated using Q norm. So this is equal to 3.52. Okay, let's look at one more example. Suppose the test scores in an exam is approximately a normal distribution with a mean of 80 and standard deviation of 10. The first question, what is the probability of an individual scoring between 76 and 88? So let's look at the first one. Let x be equal to the test score. According to the assumption, x is a normal distribution with a mean equal to 80 and sigma squared equal to 10 squared, because standard deviation is 10. We want to calculate the probability x is between 76 and 88. We're going to use the same technique as before. Probability equal to, this is equal to the probability. We subtract the mean divided by standard deviation, 10. And this is less than or equal to 88 subtract 10, 80 divided by 10, greater than or equal to 76 subtract 80 divided by 10. And this is equal to probability negative 4, negative 0.4, less than or equal to z, less than or equal to 0.8. This is equal to probability of z is less than 0.8, subtract probability z is less than negative 0.4. And this is equal to phi of 0.8 subtract phi of negative 0.4. And this is equal to, we can use R to calculate this. P norm 0.8 subtract P norm negative 0.4. And this is equal to 0.44 roughly. So this is roughly 0.44. Now let's look at the second question. How high an individual has to score to be in the top 5%? In other words, we want to find A such that the probability X is greater than or equal to A is equal to 5%. Now, using the same technique, we have a probability minus 10, X minus 80 divided by 10 is greater than A minus 80 divided by 10. And this is equal to probability Z is greater than or equal to A minus 80 divided by 10. And this is equal to 1 minus probability Z is less than A minus 80 and divided by 10. And this is equal to 1 minus phi of A minus 80 divided by 10. And we want this to be equal to 5% or 0.05. So phi of A minus 80 divided by 10 must be equal to 0.95. So A minus 80 divided by 10 is equal to phi inverse 0.95. We can solve for A. A is equal to 10 times phi inverse 0.95 plus 80. And again, we can use R to calculate this number. 10 times Q norm. Recall that the inverse function of standard normal can be calculated using Q norm plus 80. And this is equal to 96.4 roughly. So this is roughly equal to 96.4. Thank you for watching.